find this limit. When x approaches 0, this limit. This example, the main purpose of this example here is that sometimes use calculator will lead to a wrong direction, a wrong answer. Because no matter what x is, 5x is a real number. The denominator, this one, whose size never greater than 1. So this term is very small, very small. And when x approaches 0, this is also 0. So sometimes use calculator, you might guess this limit is 0, but this is wrong because when x equals 0, this is 0. When x approaches 0, this is 0. 5 times 0. 5 times 0 is 0. 10,000. 10,000. So the answer should be 10,000. Okay. 1/10,000 or 0. How many zeros? 1, 2, 3, then 1. Okay, if you use calculator, you might guess, oh, the limit is so small, so the limit is 0. But because the denominator is too large, will lead you to a wrong direction. Okay, so the calculator may fool you. Example 3. Okay, example 4 already solved. 4 also solved. 5. Oh, in this example, the limit does not exist. Okay, investigate. 调查一下，研究一下。Investigate to find it out, find the truth of this one. Here we have, I think the best way to realize this problem is to sketch the graph of this function. Sketch the graph of this function. So first, let's sketch the graph of sine function. Sine. What is sine? What is sine? -1 plus 1, this is the origin. 1, 2, 2 pi x half pi. Three half pies. Well, suppose we have the arc length is x. Then the cosine of this one will be cosine x, sine x here. This is maybe u axis, v axis, but here x axis and y axis. When x is very small, here, by this limit, we know the graph of sine and the x almost the same. Almost the same. But we have this inequality. If x between 0.5 pi. So sine must be lower than this one if x is large. But when x is very small, okay. Use the notion, the concept of limit. Enlarge, zoom, zoom, zoom. And finally, because this part is smooth, if yes, as I said, if you were a creature living in this small world, you cannot find your world is curved. You think your world is a straight line, a vertical line. Okay. So here, what you have will be this is cosine x, sine x. This is also x. Because x is so small. These two are the same. Means this is a tangent line. But when x is larger and larger from outside, we human being realize, this is x, and this is sine x. Sine x should be smaller than x. But when x around almost half pi here, again, is the notion of limit. The behavior of sine is extremely determined by the behavior of the circle. Zooming, zoom, 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 zoom. Then here will be a horizontal line. And in this case, 0, 1. And maybe this is cosine x, sine x. Sine is the y coordinate, almost the same value, almost 1. Means the graph of sine around here has a horizontal tangent. And also, each part, zooming, zoom, 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 is a straight line, means the graph should be smooth. Finally, tangent, always smooth, locally a straight line. So graph of sine in this part will be looks like this, a horizontal tangent. Sine almost 1. Almost 1. This is 0, 1. Okay? Do you know what I mean? I mean, this portion, zoom, 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 becomes to a straight line. And the sine is exactly the same height of this point. So sine almost 1. And when x is pretty close to 0, x is very small here. I mean, zoom, 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 you will see, aha, if you are a preacher, so limit means you can pretend you are very small, like a virus. Okay, living in this part, you can look around, you are inverse, universe. Aha, straight line. In the future, this notion is differentiable, smooth, differentiable. If the graph without any gap is continuous, continuity, differentiability means smooth. Okay, locally is a straight line. And far away from, we can see this straight line becomes to tangent line. Locally straight line, but far away from our human being, there is a tangent line here, a tangent line to this curve. Okay. Now, if x is greater than half pi to pi, to this position, then the value of sine will be from 1 drop to 0. The behavior just like how increasing, now how decreasing. So we have this is minus 1. Slope is minus 1. Okay. Negative also from 0 to negative 1. From 0 to positive 1, but from 0 to negative 1 with the tangent whose slope is minus 1. And by the periodic property of the sine function, the graph of sine function should be like a wave shape. Copy this. Okay, so this is y equals sine x. Okay? This is the graph of the sine function. Shoo, 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 shoo. Copy this shape. Infinite many times. Okay, so, but what is this one? What is this one? when x is small, sine x almost x. So this linear function stands for the tangent line to the curve at this position. Sine, slope 1, 0, minus 1, 0, plus 1, 0, minus 1, 0, plus 1. Periodically, minus 1, 0, and so on. Therefore, the maximum of sine is 1. Minimum value of sine is minus 1. And sine x equals 0 if and only if x equals 0, pi, 2 pi, 3 pi, 4 pi, or minus pi. Yes, multiple of pi. Okay, integer multiple of pi. Very good. So, now consider the graph of this one. No matter what x is, if x is non-zero, this is a real number. So the value of sine always between minus 1 and 1. Okay, and when this value is 0, pi, 2 pi, 3 pi, 4 pi means pi means 1. 1, this is pi. 1/2, 1/2, 2 pi is 0. And 3 pi, if 1/3, 0, 4 pi, 1/4, 0, and so on. 1/5, 1/6, 6/5, 7, 10, and so on. Okay. Next, if x from 1 decrease to 1/2, then pi over x will from pi to 2 pi. So the value will be from 0 to minus 1, then to 0. 0 to minus 1, then to 0. So maybe it looks like this. Okay, take a break. I will finish this.